Hello everyone. So today let's solve the problem Igor in the museum, right? Igor in the museum. Sorry. Yeah. This one was asked in the educational code forces around one actually. Oh, code forces around one. This is fine. Yeah. Now, let's do one thing. You can just go through the question. I'll just summarize the question so that it will be easier for us to solve the problem, right? So let's see what the question states here. Now, Igor walks on empty cell. So empty cell is represented by dot. Just remember this. Igor walks on empty cell, nothing but the dot of an n into m grid, right? Of an n into m grid. Later, we'll be looking into the input output part as well. So in that, you'll get to know clearly, right? Igor walks on the empty cells, nothing but represented by the dot here, of an n into m grid. Each side between an empty cell and an adjacent this one impossible cell, adjacent impossible cell is represented by the star. Remember this one, star, right? So Igor walks on an empty cells, this one on empty cells dot of an n into m grid. Each side between an empty cell and an adjacent impossible cell, nothing but the star here, has one picture, has one picture, right? So from a starting empty cell, so from the starting empty cell, from the starting empty cell, Igor can move inside its connected empty region. Igor can move inside its connected, move inside its connected empty region and will see every picture adjacent to that region, right? And will see every picture that is adjacent to that particular region. For each query here, for each query, what we have to do for the each query, nothing but the starting cell, we have to print the number of pictures, number of pictures here. For each query, we have to display or print the number of pictures visible from that connected component, visible from that connected component, right? So visible from that connected component, right? So this is fine. So this is the question basically. Yeah, let's move on with the input output part. Just give me a second here. 1 second. Yeah, now we have the input output part 563, this one actually, right? So this is fine, man. Yeah, 1 second. So this is actually this one n 5 into 5 grid. So this one we have 6 actually, 5 into 6 actually. Yeah. So this one, see, 5 rows and the 6 columns. So this is fine. N M as well as the this one. What do you call this? 3 is nothing but the Q actually. N M Q they have given here. N M Q. N is 5 rows. This one 6 1. This one 6 columns. You can count here. 1 2 3 4 5 6 actually. Yeah. This is nothing but the 3 queries. Yep. So the output that we need to get here is so basically, what is the output? The number of pictures visible from the particular component, right? So we have to go with a this one. Print the number of pictures visible from that particular point, right? For the each query. For the first query, double two, we have the output 6. For the second query, we have 4, and for the third query, we have 10. So this is about the input output part. So we are not considering how we got the output. I just wanted to show you the input output part. Now let's discuss the approach. So the first thing I want to tell you here is to solve this particular problem, we will be going with a DSU, disjoint set union, or the union find, right? With a path compression, right? So now this is fine. Now let's move on this one. Let's move on with the approach basically completely. So let's consider the same first example, man. So that after discussing the approach, you can consider or you can try to implement the same thing on the example 2, right? I insist you to do that so that you understand the question better, right? Or the problem better. First step here, we will be treating, so this is just the idea. Let's discuss the idea. As I've said, we'll be going with a disjoint set union with a path compression, right? So we will treat, this is just the idea. We will treat every empty cell in the sense dot here. We will treat every empty cell dot as a node. We will treat every empty cell, nothing but dot as a node, and we will join DSU by this one. We will join DSU by unite basically, right? So we will join or unite. So this one DSU bar unite. So adjacent cells in the sense, so next to this one, adjacent cells next to empty cells I'm speaking of, right? This one adjacent cells, right? So this is fine. This will be, we'll be checking with the 4 neighbors actually. It can be up, down, this one, left or right. This is fine. Yeah, we get the connected components of the empty spaces. We get the connected components of the empty spaces. So this is the first point that we will be doing, right? So the second thing will be for each cell, meaning for each neighboring this one, for each neighboring blank cells or the dot cell, increment that particular dot, increment that, or let me give here for the increment, let me make use of the double plus here. We will be incrementing this one, uh, empty cell or the dot cells component picture. We will be counting this one by one. Will increment or will be increasing the count by one basically. Each adjacent is a picture for that particular component, right? So we'll be incrementing. If we find the same, this one, what we call dot, basically blank cell. So let's move on with the third point. I hope this is fine, man. I hope this is fine. Now, let's move on with the third point here. After pre-processing for any query x comma y. So this is represented by x for any query x comma y we are considering. This is represented by the y. So for after pre-processing for any query x comma y, we will be outputting the pre-computed picture count. We will output the pre-computed picture count of the component that contains the cell x comma y, that contains the cell x comma y. So this is fine. Now let's move on with the example query. So this is the idea basically. This is the idea. Now let's move on with the this one. What do we call queries actually, right? So I'll just mention DSU. We are going with the DSU. We have discussed the idea how we'll be making use of it, right? So this is fine. Now let's go with the example queries. Man, first one, let's consider 2 comma 2 here, or let's go with here 2 2, right? So this is fine. Let me go with 2 comma 2 here. So this is the first query. So this belongs to the smallest component on the row 2. So this belongs to the smallest component on the row 2. See here, this one row. So this is row 2, right? Row 2 dot. This is the first blank cell, right? So here you can clearly see. So 2 2, uh, so 2 2 here. So this belongs to the smallest component on the row 2 actually. Row 2, right? Smallest component on the row 2, and the column 2 3, and the column 2 3, right? So column 2 3, this one, right? So this is fine. Yeah, that component is adjacent to this one 6, nothing but the star sides. So output, what we have to output here, we have to output 6 here in this case, right? So now let's move on with the second query, nothing but the 2 comma 5, right? So 2 comma 5, 2 comma 5. So this one, this is isolated, you can clearly see this one, this dot in the same row, this is isolated between two stars actually, two blocked or two stars actually, right? So this is the isolated single star. So this is the isolated, isolated single, this one blank cell or the dot, right? At 2 comma 5, which is adjacent to 4 star sites, which is adjacent to this one 4 star sites. So this one 2 comma 5 we are considering. So output, we have to output 4 here in this case, right? So for this one we have to output 6, and for this one we have to output 4. Now we have the clarity. For the third one, we consider 4 comma 3. For the third one, we'll be considering 4 comma 3. For for this one, for this query, component of the row 4 columns. So this one 4 comma 3 comes here. This one 4 comma 3. This one we have to consider, right? So this one basically, yeah. This one dot 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 we have for this one component of row, this one 2 comma 5, total adjacent star, that is sites counted. You can just count this one. We have 10 actually. We have 10, right? So component of row 4, column this one 2 to 5. So total adjacent star sites counted is 10 actually here in this case. So here we have to output 10, right? So we have got the output 6 4 10 here, right? Accordingly with the criteria of the question that I mentioned, right? Or accordingly with the approach that we discussed. So the same thing we have implemented here for the queries. So now the output that we got here is 6 4 10, which is equivalent to the output that they have given for the example one within the question, right? So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to because of um, n into m here, because of n into m into, so this one a is nothing but the inverse Ackermann, right? So this one again n into m here, n into m. So this is almost equivalent to because of n into m. Let's do one thing. Let's consider this one itself. of n into m as the time complexity, right? So the time complexity would lead to big of n into m because we'll be going with a DSU, right? Disjoint set union, and building the DSU unions and iterating the neighbors dominates here, right? So overall time complexity would lead to big of n into m. So a, whatever I have used, a is nothing but the inverse I common, right? So which is basically effectively constant. So that is the reason I considered this one itself directly, right? Rather than big of n into m into a of n into m, right? So this would remain relatively constant. So I considered this one big of n into m directly. So what will be the space complexity here? The space complexity would lead to big of n into m as well, right? So we will be making use of the arrays parent, this one, parent array, size array, count array, and the grid store per cell information. We'll be going with a grid store per cell information, right? So overall space complexity would lead to big of n into m as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n into m and big of n into m respectively, right? So now, as we are completely familiar with the approach and the complexities, let's do one thing. Let's start writing the code, right? So first thing here, I'll just will be making use of the this one, what do we call fast input output, as well as the what do we call utilities, different utilities, right? So let me import the input output package along with the this one, what do we call utility package. Till this is fine. Now let's go with the class uh, main. So within the main method, let me do one thing. Let's go with the n, m, and q. Nothing but so this one, rows, columns, and the number of queries, right? So this one I'll just go with static n, m. This is fine. Now the next step would be we'll be going with a DSU parent. We'll be going with a size, and we'll be going with a count, right? So this one I can just write it in this way. Static. So this one will be int. So yeah, I'll just go with a parent. So let me go with the size as well. Let me go with a count, CNT. Now let's do one thing. Let's go with a grid, four direction row deltas, as well as the four direction column delta. So I can, for the grid, I'll just go with a static here. So this one will be char. This is fine. Next, let's go with the four direction row deltas one. So I'll just go with the static here. Int equals, so 0 comma 0. I'll just go with 1 as well as the minus 1. Yeah. Now the final one would be, let's go with the four direction column deltas as well. So this one will be static int. I'll just go with a dy. That is equivalent to minus 1, mm, 1, 0, and yep. Now, yeah, we are done with this part. So now let's go with a find with a path compression, meaning we have to return the representative, right? Or root or the parent of the x within the find. So we know this one, right? If you know the algo, we always have to return the representative, or we have to find the representative or the parent here. Also, we'll be going with the path compression within the find always. Let's write the find method here. This one will be static and find. This is fine. I'll just go with a int x here. So within this find method, if x is root, then we have to return it. So if parent of x, if it is equivalent to x, then we have to return x. This is fine. Next, otherwise we have to compress the path and return root. So I'll just go with return parent of x equals find of this one. What do we call parent of x? This is fine. Yeah, let me come out of this one entirely. Now let's go with the union by size, right? So union by size. So we will be going with a union by rank. Union by rank. In this case, rank will be considering size actually, right? So we will be merging as well. So we'll merge sets containing A and B within the union. So I'll just go with static here, void. So let me go with the union, or let me go with the unite. Anything. So this is fine, right? the word that I found relevant here as unit. Basically, I'll just go with the unit itself. So I'll just go with the int a and b as the parameter. So within this method, let's do one thing. Let's find the root. So this one will be a find of a. This is fine, and b equals find of, yeah. Now this is also fine, man. So let's go with the already same component, meaning here if a equals b, then let me go with the return. We have to exit, so I'll just go with the return keyword here. So we have to ensure a is the larger set here, right? So let me go with the simple if condition here. If size of a, if size of a, if it is less than size of b here, if it is less than size of b, then let me go with int t equals a, right? T equals a equals b, as well as b equals t, right? So this is fine. So we are just swapping a and b here, right? So let me do one thing. Let's move on with the further things. We have to attach root b under a. So I'll just go with the parent a here. Parent, sorry, this one has to be parent b, right? So we are attaching the root b to the parent, this one, root b under a, right? So we have to assign this one to the a. This is fine. Next, let's update the size of the root element. So this one, according to with the algo. So this one we have to go with the size of a equals size of a plus size of b. This is fine. Yeah. Now let me go with the count of a. Count of a equals count of a plus count of b. Count of a plus count of b. So let me come out of this one entirely. Now let's do one thing. Let me go with the main method. So this one, let me remove this one from here. I'll just add throws input output exception. Yeah. Now within the main method, so let's go with the this one. What do we call? Input output related things first. So let me copy this one. Let me copy paste this one. Just give me a second. Just paste this one. This is purely related to the input output, man. Buffered reader for the fast input print writer, for the fast output string tokenizer, we have to read this one. What do we call? 563, the first line. And we have to parse this one. This is of the type integer n, m, and q. So this one is n, nothing but the rows. This one is nothing but the m, nothing but the columns, and this three is nothing but the queries, right? Number of queries, three. Yeah, this one we are doing. So this is fine, I believe, easy. Yeah, the next step would be, so let's read the grid rows. When I say let's read the grid rows, I'll just go with for int I equals 0. This one will be I less than n. So this one will be I plus plus. So g of I, let me assign this one to buffered reader dot read line. So this is fine. I'll just go with to char array. This one is fine as well. To char array. Yeah, so we're just reading the grid rows here. Next, let's move on with the further things. First, let's go with the total cells, man. Total cells meaning, let's go with the flattened indices. Um, go from a 0 to total minus 1, right? So I'll just go with n into m here. N total equals n into, and this is fine. Sorry, this one has to be the multiplication operator. Yep, we have to assign parent this one, right? Size actually. Let's go with the DSU parent array. Let's go with the DSU size array as well as the pictures, picture count for the component root. So these three things, I'll just assign parent to new int of total. The second one is size actually. Let me assign this one to new int of again this one total. This is also fine. The final one is count. Count equals new int of let me go with the say total. Let me pass total here. This is fine. Let's move on with the iteration part, man. Now, yeah. So I'll just go with for and I equals 0, I less than total. This is fine. Let me increment I. Yeah. So within this for loop, let's do one thing. Let's initialize each node as its own parent. So this one will be parent of I. This one is fine. This one will be parent of I. Let me assign this one to the I. Next, let's go with the size of I and let me assign this one to the 1. This is fine. Let me go with the initial picture count and let's assign that one to the 0 basically. So this one will be count of I. Let me assign this one to the 0. Let me come out of this for loop entirely. Now we have to unite the adjacent empty cells, nothing but the dot, to build the connected component. So this is what the question is asking. Let's do the same here. Let's do this one quickly actually. Just give me a second here. Two things we have to do. One is we have to unite the adjacent empty cells to build the connected components. Next thing is for every star, meaning the cell with a star, right? So we have to increment the picture count of each neighboring dot component. These two things we have to do. First, let's move on with the uniting adjacent empty cells dot to build the connected component. So this one is we have to go with the two for loops, right? So this one int I equals 0, I less than n. So let me increment I here again. So this one will be for int j equals 0, j less than m. Let me increment j. So this one within the two for loops, first thing is we have to skip the impossible cells, right? So impossible cells, not the impossible. Impossible cells. So this one, what if c of I j? So this one, if it is equivalent to the star, then what we need to do? Then what we need to do? We have to skip. In that case, I'll just give the continue keyword. This is fine. Yeah. Now we have to flatten I comma j to id. So this one will be int id equals uh, I into m plus j. This is fine. Yeah. Now after flattening I comma j to the id, so we have to check all the four directions, left, right, up and down, as we had discussed in the approach. Let's do that. For that, one more for loop here. This one int d equals 0, d less than four directions we are going with, starting with 0, right? 0, 1, 2, 3. So this is fine. Yeah, d plus plus. So within this for loop, let's do one thing. Let's go with the neighbor coordinates basically. So I'll just initialize ni to this one neighbor I. So this one will be I plus dx of d. This is fine. Nj equals. So let me consider here j plus dy of d. Yeah, we are just assigning the neighbor coordinates, right? So now let's go with the boundary check, right? So I'll just write this one very quickly. So this is important as well. So this one, if ni less than 0 or nj, if it is less than 0, or so what if ni, if it is greater than or equal to n, it shouldn't be, right? So and also nj here, what if it is greater than or equal to m? In that case, we have to skip. So let me give continue here, continue keyword. After boundary check, let's do one thing. Let's only unite with empty neighbors, right? So I'll just go with if here, if g of ni, g of ni, nj, nj. So if it is equivalent to this one, star actually, then let me give continue keyword here. Let me make use of the continue. Only unite with the empty neighbors. The next one here would be, let's go with the union current and the neighbor. So let me make use of the unite helper method that we have written. Unite, let me pass id here, ni into m plus n, ni into m plus n, right? So this is fine, man. Yeah. Now we went with the union current and neighbor. So this is going to be the last, right? So this is fine. Now let me come out of this one entirely. Yeah, I have left the space correctly here. This is fine. For every star cell, right? So for every cell containing the star, we have to increment the picture count of the each neighboring dot component, right? So that's what we need to do. So let's do that one very quickly. Exactly the same thing we have to do. Right here. Have to do the same thing or what? Let me do one thing. Let me copy this one and make the necessary changes here. Yeah, this one remains same. I equals 0, I less than n, I plus plus. So this is fine. J equals 0, j less than n, j plus plus. So again, we'll be going with if j of ij equals instead, yeah, this also remains same, right? So we'll be checking with star, right? So for each impossible cell, we will be going with. Now If d equals 0, again the four directions. This is fine. Ni equals I plus dx of d, nj equals j plus this one dy of d. This also remains same actually. This is again we have to go with a boundary check. If ni less than 0 here or nj, so this is a boundary check remains same man. Yeah, this bounds basically. So it shouldn't be less than 0 and it shouldn't be greater than or equal to n and m. So this one ni and nj. So this is fine. Now we have to consider only the neighboring empty cells, right? So this one g of ni nj, if it is equivalent to star, so this is also fine. Will we have to skip in that case? We'll be giving this one continue. The only thing that will change here is instead of the unite function, we will be going with a find basically. So this one has to be count of find, right? So within the find, what we are doing, we went with a path compression along with finding the representative or the root of x, right? So this one will be making use of helper method find. So this one will be find of ni into this one m plus n here. So this is fine. M plus nj actually. M plus nj. So let me increment this one. This is fine. We have just increment the picture count of that component, right? So this is fine. Let me come out of this one entirely now. Yeah. So now we are left with only quite a few things. So we have to answer the queries, meaning we have to print the count of the component containing the queried cell. So let me go with a while loop here. While, so this one, if it is greater than 0, then st equals string tokenizer. So this one will be new string tokenizer. So this one buffered reader dot read line. Anyways, this is fine. Yeah, we are just reading the query here. Now we have to convert one based row to zero based. Also, we have to convert one based column to zero based, right? So this one will be int x equals integer dot parcent. So this is fine. This one will be string tokenizer dot. We have made use of the next token. Yep. As it is uh, zero based, we have to convert one based row to zero based, right? So this one will be minus one. Yeah. Now let me do the same thing for y as well. Let me copy this one entirely and let me go with a int y this time. So this remains same. Yep. Now we have to print the picture count for that particular component, right? So I'll just go with the out dot println here. So this one will be count of, let me go with the find here. So this one x into hmm, m plus y, m plus y. So this is fine. Uh, this is fine. Let me come out of this one entirely. Let's ensure the output is written, man. So out dot flash. So this is fine. Yeah. So we are just ensuring the output is written here, right? So we are done with this part. Right? So somewhere I have missed something. I don't know what I have missed. Somewhere I have missed something. So bracket actually. Just give me a second here. So let's see what is the mistakes we have done here. So this one I have to go with the int, I believe. Yeah, static int element q, right? So we don't have to mention array for this. This is fine. And here I have given int n and int b. So this has to be int a and int b. So this is also fine. Mm, so before checking for the bugs, let's do one thing. Let me copy paste the signature starter template one. We are done with the code, right? So just give me a second here. So I'll just come here. Let me paste this one. Yeah. Let me come to the question now. Let me copy this one. Let me paste this one. We have to get 6, 4, 10. So we have some error here. Illegal start of the type. While identifier expected 3 errors we have here. Identifier expected. Okay, fine. Mm, Again, the same thing actually. Flash 101. Identifier expected. Mm, One second. So I'm not understanding what is the mistake I have done. So let's look at the code correctly, man. So that we'll get to know something. So within the unite method, so here this one has to be ni into m plus nj actually, right? So we have considered the variable nj, not the n. It will consider rows actually, right? So now we are still with left with the three errors actually. Let's check actually. Bracket, somewhere I have missed some bracket. I don't know where. Just check. Let's check. So I need to give another bracket, I think here. So this is fine. Let me run this one. So let me change this. Oh, this one I have to go with the capital I, man. This one also I have to go with the capital I. Yeah. Now these error has to be gone actually. No. Since this is fine. 1 second. String tokenizer st we have considered. Dot next token. This is fine. -1. Yeah. Buffer data dot read line. So this is also fine. Yeah. Now this is fine. So it was the problem basically related to the this one bracket actually. I had misplaced the bracket actually. That was the main problem. So now this works absolutely correct. Now this works absolutely correct, right? So when I run this one, we are getting the output 6410, which is absolutely correct, right? So this was one of the mistakes actually. I had to give nj. I had to give nj instead of the n, right? So this is fine. Now this works absolutely correct, right? So this is fine. Let's do one thing. Yeah. Now let me copy the entire code. Let me come here. Let me hit the submit code here. Let me paste the code. This one problem D, right? Igor in the museum. Igor in the museum. Yeah. Let me hit the submit button. Let's wait for some time. I hope this works for all the test cases. So bracket was the main problem actually. I misplaced the bracket actually. Yeah, you can clearly see here, this is getting accepted in the toast. It is showing accepted, right? The verdict that we got here is accepted. So we have went with pure DSU to solve this particular problem, disjoint set union, right? So unite and the find method you can clearly see. By looking at the set self, you can clearly see. You can clearly tell, right? So this is fine, man. Yeah. Now, yeah, I hope the solution part is completely clear. So one thing, the main mistake was actually we have to move this one while loop outside from the main method, right? So that's what we had to do. It was inside the main method. Yeah. uh, that one I had to do. So that's fine. Now this works absolutely correct, right? So this is fine. Yeah, I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.